Moving on with example 5 and 6. Example 5 is dealing with reversing the inequality symbols. And if you remember, the only time you need to worry about that is if you are multiplying or dividing by a negative. So of course this is going to be an example of this. So it says solve and then graph the solution again. Same rules we always did. Let's deal with our constant terms first. So my constant term here is a negative 2. I want to get my variable by itself, so I'm going to add 2 or combine that with a positive 2. I'm going to do that here. Sorry, I switched colors just because I realized that one matched my background a little too much. So all three parts of the equation we need to do that with. Negative 2 combined with a positive 2 is going to give me 0. Keep my inequality symbol. Negative 2 combined with a positive 2 gives me 0, but leaves me with a negative x. And a positive 1 plus 2 gives me a positive 3. Keep your inequality symbol. Now, I do not want to solve here for a negative x. I need to solve for a positive x. To do that, I need to do each part of my equation needs to be multiplied by a negative 1. Now we discussed this shortcut would be just changing the signs to their inverse. But I wanted to show you what you were actually doing. You're multiplying everything by a negative 1. When you're multiplying or dividing by a negative, you want to make sure that you change your signs. So now I'm going to have 0, reverse my sign. This is now going to be an x. I stayed with 0, I'm sorry, I didn't say that. 0 times negative 1 is still 0. Negative x times negative 1 gives me a negative times negative gives me a positive. And 3 times a negative 1 gives me a negative 3. Now you'll notice in this situation, we are not in descending order, reading from left to right. So I'm going to rewrite that as a negative 3. Make sure you watch what you do with your sign. The sign was pointing at the negative 3. I want it to still point to the negative 3. Put my x in there. And then notice here, my other term is 0. And the open part was by that, which it still will be when I do it this way. The reason I did that again was I wanted it as a number line. I would see negative 3 to the left of 0. Let's go ahead and take a peek at that number line and see how they shaded it. And again, it's a compound sentence, so it will just be shaded in between. Moving on to example 6, we're going to talk about some real life problems. I cheated a little and used the graphics from the book for this one. You have a friend, Bill, who lives 3 miles from school. And I'm going to go ahead and I'm going to write 3 miles in here. Actually, I should do it on the next screen, but I'll do it on both. And another friend, Mary, who lives 2 miles from school. From the same school. You wish to estimate the distance between the separate homes. We're going to have 3 different questions here. What is the smallest value that the distance could be? What is the largest value that the distance could be? And distance is marked by the variable d, or represents the variable d. Write an inequality to this that describes all the possibilities. So I copied that a little bit smaller here, but let's do this. Mary is 2 miles, and Bill is 3 miles. Then we can see that a little bit easier. So the first way we could do this is just by drawing a diagram. They did one as a circle, which is perfectly fine. They have school in the center. Then the red here is Mary's home. She's 2 miles away. And then the blue here is Bill. He lives 3 miles away. He could live anywhere on this circle, same as Mary could live anywhere on this circle. Okay. Let's go ahead and then look at what we need to do after we have our diagram. Now, the diagram I kind of split into 2 here. I didn't, the book did. So if we look at the first question, what is the smallest value? We're going to say that they live in a straight line to each other. We don't have to consider anything else. Okay, they live straight from school. You follow one path and get to both of their homes. Now, if that is the case, then when we're at Mary's and we want to travel to Bill's, Mary's was at 2, Bill's is at 3, so the difference was 1 mile. Now, the largest value would be if they lived opposite directions from school. So they go the opposite way when they leave school. Again, their houses haven't moved how far they are, but if I go to Mary's, I'm going 2 miles to the, we'll say, lower left, and Bill's now, I'm traveling 3 miles to the upper right. So if I'm coming from Mary's here and traveling all the way to Bill's, I have to travel my 2 miles to get to school, and then my 3 miles that Bill always travels from his direction to school. So that would then give you 5 miles as total. So we go to our last one where we're actually writing the inequality. The least it could be would be that there's a 1 mile difference. The biggest it could be is there's a 5 mile difference. And it could be equal to exactly that, if they were exactly in line or exactly in opposite directions. So our inequality sentence, again, writing the smallest value first, 1 is less than or equal to the distance, which is less than or equal to 5 miles.